we got integral of 5 times quantity tangent square plus tangent to the fourth with respect to x. And we know that the issue here looks like with fourth power, because with only tangent squared and this 5 times, we can simply pull 5 all the way outside, nothing to worry about 5 because it's 5 times. Tangent square we can simply integrate this way. We know that 1 plus tangent square is secant square. We know this identity. If we subtract 1 from both sides, we get tangent square equals secant square minus 1. So this is simply secant square minus 1. Then we can integrate. Antiderivative of secant square is simply tangent, because derivative of tangent is secant square, minus antiderivative of 1 is x. So nothing to worry about tangent square, but tangent to the fourth, and we don't have direct formula. We have formula for tangent square, by the way, like this. This one is tangent square is, I just wrote here, secant square minus 1. So tangent to the fourth, and we have only this formula available. We need to write down tangent square and go from there. Let's see. I don't know, it's just playing around. So tangent to the fourth, hopefully this works. Okay, that is tangent square. Okay, and tangent square is pretty much secant square minus 1, that quantity square. Then we will have secant to the fourth. That's not helping. And we know that derivative of tangent is secant square. How about writing tangent to the fourth as tangent square times tangent square? Then if we simply change one tangent square as secant square minus 1, then we have tangent square times quantity secant square minus 1. And we know that derivative of tangent is secant square. That means we can use u substitution. So we need to go into this approach, okay? So tangent square is tangent to the fourth as tangent square times tangent square, and tangent square is secant square minus 1. And the first part was not bad. Okay, let's do it. So I can simply pull 5 outside. Inside is now tangent square plus tangent to the fourth is tangent square times tangent square. And I'm going to write that tangent square is secant square minus 1. Okay, tangent square is secant square minus 1. Now let me distribute that. So 5 all the way outside, and we have tangent square here. We'll take care of this later. Plus this times means distribute. So tangent square times secant square. You know, for this part, we can simply integrate using a u substitution, because your u is tangent and derivative of tangent is secant square. So a simple u sub is good enough for this one. Minus, I'm distributing tangent square. Tangent square times 1 is tangent square. And all over dx. We got 3 terms. Oh, this question is easy now, because now we can cancel positive tangent square minus tangent square. Okay, or we can, in fact, I mean, if they did not cancel, we had to change this in terms of secant square minus 1 and integrate. But in this particular question, they cancel, so that's easy. 5 left over is now tangent square x secant square x dx. Now I'm going to use u sub, but just use the short form. From here, if we say u equals tangent, you can show the work, but by now you should be quite familiar with this. and derivative of tangent is secant square. So this one is pretty much du. Derivative of tangent is secant square, and we can move dx to the other side. So this question is pretty much now u is squared, because tangent is squared, du. Okay, so this is u is squared du. Okay, or you can do u sub. Then antiderivative of u squared is u 3 over 3. Done. So that is 5 u3. U means tangent. Tangent 3 over 3 plus constant. Final. This is 5/3 tangent cube x plus c. Final.